All right, we are going to go ahead and get started. So hi, everyone. Good afternoon. This is Tara Van Cleve, and welcome to the Storage Services Cloud Coaching Office Hours. Before we get started, I'd like to provide some brief information on what cloud coaching is and how to request your own cloud coach. If you're experiencing a roadblock that isn't serious enough to warrant a service request, or maybe you just purchased OCI and are looking for an additional onboarding session, cloud coaching clinics pair you one-on-one and with a cloud engineer to assist you on your cloud journey. So we offer workshops and demos for deeper dives on a particular service, provide sample code and provision and configuration services. So I will go ahead and drop the link in the Zoom chat now, and please feel free to also ask your questions throughout the presentation in the same chat. So here is that link. And please also note that this session is being audio taped and will be available after the event to view at your convenience. So we'll send out a link via email in a couple of days. And without further ado, please welcome our cloud expert, Tom Fu.
Hi, y'all. My name's Tom. I'm a cloud engineer here at Oracle. I'm based in Austin, Texas. So howdy. I hold certifications in a number of Oracle and AWS cloud-related technologies. Today, I will be your presenter for this cloud coaching session on cloud storage and the services that we offer at Oracle. First is just standard safe harbor statement. Maybe just take a few seconds to read over it. And here is a table of all the cloud storage services that we offer at Oracle. I will talk about each of them in later slides in greater detail. But first of all, I want to give you a brief high-level introduction to them and describe them a little bit so you know and also get some idea of how they're different. Starting from the left to right, first we have local NVMe. Local NVMe comes with some high-performance computing shapes, and then they are non-persistent. And some use cases include big data and HPC workload. To put in some simple, like the term that you might familiar with on-prem or on your personal PC or something that's not related to cloud. So local NVMe is like a hard drive that's built into your computer. You cannot take it out. It's part of your computer. Once your computer is dead, then the hard drive or the SSD drive inside the computer is dead as well. So it doesn't persist beyond the lifespan of your computer. So think of it like a SSD hard drive on your computer. Next on the table, we have block volume. Block volume is a storage that you can attach to any compute shapes or any compute instance, and then the block volume is persistent, and then it persists beyond the lifespan of a compute shape. So you can think of it in a familiar term like a flash drive or like a USB drive that you can plug it in to your computer, and then you can unplug it and plug it into another computer to perhaps transfer data, or also maybe just to save some like longer term data that you might find it useful later on beyond the lifespan of your computer. And the third one on the table is file storage. File storage is used for building out a shared file system. Mostly the use case include like HPC or microservices architecture. So that's about file storage. So like think about it, file storage in like a simple term will be like in your local network, you have a server that is hosting all the data, all the files that everyone in the network can access to. So that would be kind of like how you can picture file storage to be. Last two on the table are object storage and archive storage. They are for storing unstructured data independent of any compute shapes. So you can think of them like Dropbox or Google Drive. So you can just like upload files or data to them directly from your browser. Obviously, object storage and archive storage has more like functionalities for developers rather than for Google Drive or Dropbox for consumers. The use case for them are generally just storing unstructured data, and then those data can include like very large images, video, or log files. You can access, or you can upload data to them, or you can download data to them. You can access them using APIs, also command line interface, and also using the console on the website. One way that these two, object storage and archive storage, are different than all the three that I mentioned earlier is that you don't need to spin up any compute instance in the Oracle network in order to use them. They are independent of any compute instance. You can just create a bucket in your account and then start uploading to the object storage right away. So if you're new to the cloud world or new to cloud technology, I think object storage and archive storage are the easiest thing that you can use, and then the easiest thing to play with. That's just my kind of personal experience. And also, they're the cheapest among all. They're the cheapest. So it's good for storing large data. So this is the overview. Also, if you have any question, please ask in the comment session or the Q&A session. We will have someone there to answer questions for you. Or if you have like a longer question, I will have a Q&A sessions after all the slides. So if you have any question, please just leave it in comment below. Let's start deep diving into the first service that we will talk about. It's the local NVMe, and then it's the first one on the table. So local NVMe usually come with some high performance workload shapes. So in some instance shape, they're included. Here on the bottom left of the slide, you can see all the shapes that will include some NVMe storage. In general, the stronger the shapes are, the more local NVMe storage that you will get. As you can see here on the like a table of different shapes that you can get NVMe storage. So as I kind of briefly mentioned, local NVMe storage are for workload. They require high storage performance requirement. Those include like HPC and big data use case, and other perhaps some like OLTP database that require very strong IOPS workload. And also, as I mentioned briefly, NVMe storage are non-persistent, meaning that your data will be gone after you terminate the instance. So that's just something to keep in mind. So if you want to use local NVMe storage for your workload, and then if you go into delete your compute instance, you probably need to do some backup before you delete your compute instance. Just some words of advice. However, though, even though NVMe is not persistent beyond the lifespan of the compute instance, it does survive on reboot. So that is like what we're better than our industry competition, AWS. So our NVMe data can actually survive reboot. So every time you need to update your OS, every time you need to reboot your compute shape, you don't need to worry about your data being deleted doing the reboot or the update. So that's something that we do better than AWS. And here's just a quote from one of the consulting firms, Accenture. Next, we will move on to the next storage service that we have at Oracle. It's called block volume. It's the second one on the table. So block volume service let you store data on block volumes that are independent and beyond the lifespan of the compute instant. Is the example that I kind of talked about earlier, the analogy I talked about earlier is like a flash drive or like an external portable hard drive that you can plug in and plug at any time. So the data you store on it can last longer and then beyond the lifespan of your computer. You can create and attach and connect and move volume as you need it. You can add multiple volumes to the same compute shape. So it's like plugging multiple USBs. You can also back them up and then connect to another computer if you want to. Some typical scenario that you might use block volumes include you need to have some persistent and durable storage, like having a database or some app or web applications or apps, or having your OS images on the block volume, and then also expand the storage of your compute instance if you think your compute is running low on storage. So basically, that's a different kind of scenario. And then here on the slide, I include a table of the spec of the block volume. As you can see, they use the same kind of the underlying hardware is the same as the NVMe local storage. However, their block volume you can attach and detach at the same like whenever you want. But the hardware infrastructure is actually as good as the NVMe, but maybe not as powerful as those high performing ones. They're pretty good on workload. IOPS workload and throughput latency, everything is listed here. And also, most importantly, they are encrypted at rest and at transit. And then here is screenshots of how you can create and attach a block volume to a compute instance. One of the few options that I kind of need to talk about is first, the way you attach your block volume. There are two options for you. One is called pair virtualization. It's a lightweighted virtualization technique where a VM uses hypervisor API to access a remote data, remote storage directly as if it's a local device. It's easier in terms of you don't need to configure it. However, it's slower because it uses hypervisor to access the data. On the other hand, you have another way of attaching it. It's called iSCSI. It's the industry standard way of attaching a block volume to a compute instance. It's faster because it doesn't involve using hypervisor in this case. However, you do need to configure your hardware virtualization to access the block volume. So those are two different ways you can attach your block volume to your compute instance. As I mentioned, you do need to configure your iSCSI. You need to run some commands on your compute instance in order for the compute instance to know and access the iSCSI block volume. But don't worry, once you spin up your block volume, Oracle's console can provide you those necessary commands you need to run, and then you just need to copy and paste them into the compute instance and run them and access the block volume on the network. Another option I need to talk about is the read-write access of the block volume. By default, the block volume are read-write access. However, you do have other options such as like read-only, so that you can prevent any accidental modification to the block volume. And another special one is the read-write and shareable access, which is like you have one block volume attached to let's say compute instance A. However, you can let this block volume that's attached to compute instance A to be shareable to compute instance B. So even though maybe B doesn't have any write access to the compute, the block volume. However, you can still read changes on this block volume. So this is the shareable access. There are lots of maybe kind of scenario you can think of it how you can use it, but there's just one of the options that we can provide it here. Next, move on to how you can detach and delete your block volume. You can detach your block volume anytime, and just as the screenshot shows, you can detach it. And then as you can see also on the screenshot, there's the iSCSI command and information section you can click, which will show you all the necessary commands that you need to run before you safely detach. So just be mindful if you attach a block volume to a compute instance using iSCSI protocol. Next, I would talk about volume groups. So volume groups essentially is a group that places all the block volumes together from multiple different compartments or from multiple different compute shapes. You can group them together as volume groups. You can manage this volume groups, as a whole, and then manage all those volumes as a group. So, whenever you create a backup, it creates backup for all those volumes under this group. And then if you clone them or you need to do some operation on them, you can operate as a group. So it's more convenient. If you need to run backups or you need to clone them, you just clone the entire group. So it's ideal for protection and lifecycle management. So that's one of the use case for the volume groups. And I probably should mention also volume groups feature is available for free with no additional charges. Next, I will talk about boot volume. Don't worry, it's not like a new concept. Boot volume is just a special block volume for images. So for like your OS, you store on the boot volume. As you can see here, a compute instance is launched using OS image stored on the remote boot volume. And the boot volume is created automatically and then associated with the instance until you terminate the instance. However, if you want to preserve your OS, your image on the boot volume, you can choose to just like normal block volume that you can detach it. You can detach your boot volume as well, so you can preserve your OS, you preserve your image, and then next time you want to launch your image or your OS into a larger computer, a larger compute shape, you can just attach the old boot volume to the new shape and then use it again. So as you can see here, it's possible to take a manual backup, assign backup policy, and create clone of boot volumes. Next slide is just showing you the screenshot of how to customize your boot volume in terms of different size for Windows image or Linux-based image. The next storage service that I would talk about is the file storage service. It's the third one on the list. Here are some potential use cases with the file storage service. Sometimes you want to do some lift and shift of your application from on-prem to the cloud. You can set up a file service between your on-prem network and your cloud network so that your cloud network can access the same storage as your on-prem does. And then you can transit data and then sharing the same storage so that you can keep the consistency of the data. And other use cases include HPC and big data and test dev, and most importantly, maybe microservices. If you have multiple nodes running, you want to have all the nodes not only to communicate through the master nodes, but also to kind of like put all the outputs into the same shared file system so that all the result can be in one place, and or different people can, or different nodes can use other nodes outputs. So those are different kind of use case for file storage service. Next, I need to introduce you some concepts of file storage. First of all is the mount target. As the name suggests, is the endpoint, the NFS endpoint that lives in your subnet of choice. Like you can choose whatever subnet. However, your mount target needs to be in a specific AD. So AD stands for available domain. So there are two different kind of subnets. You can have the AD subnet, which is living in one data center, and then you can have another subnet that's called regional subnet, which lives in the span of multiple ADs, and then is like spread across the entire region. But for mount target, you can only choose AD specific region, AD specific subnet. And then mount target consumes 3 private IPs, 2 for the creation and 3rd for high availability. The next concept is the file system. As the name suggests, is the primary source for storing all your files in FSS. In order for you to use file system, you need to attach your you need to mount your file system into a mount target. If you don't already have a mount target, you probably need to create a new one. And then the relationship between a mount target and a file system is that each mount target can have up to 100 file systems. And then same as mount target is AD specific. You can also, if you have your fast connect or VPN set up from your on-prem environment to the cloud environment, you can access your file system through the VPN or the fast connect. And then one of the use case, as I mentioned, is the lift and shift of on-prem apps to the cloud. And then that might be one of the way you can do that. Moving on, the next concept of the file system is the path. The FSS path is the export path that's unique with a file system when it's created and associated on a mount target. As you can see here, 2 mount targets cannot have the same path, so that your client doesn't confuse which one it needs to access to. Down below, there are just some commands that you need to run in order to mount a file system in the network to a local directory on your computer instance. So that is the sample commands. Here is just actually how you can mount your OCI file system. There's something that you need to download. For Linux, you need to download like Oracle Linux and CentOS base. You need to download NFS util, and for Ubuntu, you need to download NFS the comments. And then, as I described briefly before, you need to create a directory, and then bounce your file system in the network to a local directory in your compute instance. And same as block storage ISCSI commands. All those commands you need to run in order to use your file storage are provided by Oracle once you created your file storage. And then all you need to do is SSH into your compute instance, and then copy and paste all those commands and run, and then everything should be set up. Moving on to the next slide, let's talk about security. So because your file system is not directly onto your directly attached onto your compute instance, so there might be some security concern. So who in the network can access it, who cannot. So here comes the security list to kind of limit the access to it, and then serves as a virtual firewall to prevent not authorized or NFS client to access the mount target. And you do need to open some ports on the firewall to allow certain an NFS client to access the file storage. However, you can limit the source CIDR block to say what network can access it, and then so that's like security list essentially is a firewall. So you can operate as a firewall to limit different subnets and what subnet can access it and what subnet cannot. But you do need to open some ports on the subnet of the mount target in order for other people to access it. The next one, let's talk about snapshot and backup. So snapshot essentially just provide a read-only and space-efficient point-in-time backup of a file system. And then the snapshot are created under the root folder of the file system in a hidden directory. You can take up to 10,000 snapshots per file system. If you want to take more, I doubt you will need more, but if you do want to take more, you can create a separate file system to do that. You can also restore a file within the snapshot using the command here, because essentially the snapshot is a hidden directory in the file system. You can just CP, you just copy it from the hidden directory out to whatever directory you want. So you can always retrieve it from the snapshot. And then if nothing's changed, your snapshots doesn't take up any additional storage on your cloud tenancy, so it doesn't cost you any extra money. Here are just some snapshots of like a list of different snapshots of on the cloud console that you can see, and then on the right side is how you can see it, the snapshot in the hidden directory in your root. The next one is the final two of different of the cloud storage services that we provide on Oracle, which are object storage and archive storage. So they are the last two, as I mentioned, on the table. The use case in general, just like storing unstructured data, logs, and image, they're pretty big or easier to access independent of your computer. Let's just start talking about them, like about how they're different. Like, how is object storage different than archive storage? In general, they're all object storage. They're storing files as an object, so it doesn't know what they are. They just store as objects and files. And then the standard storage tier, which kind of we talk about as just like standard object storage, is the hot tier, which is for storing fast and immediate frequent access data that you need right away, and you probably need to upload it very frequently and then download it very frequently and make changes quite a lot. So your hot tier, which the name suggests, is like the data that you need pretty handily and then use it quite often. That would be the hot tier. And then on the other hand, you have the cold tier, which, as like the name suggests, is like a freezer. You only put the stuff in that you don't need that frequently, but you need to store them for a long term. You just need them to be there. Whatever you need to retrieve from the cold tier archive storage need to be first restalled before you can download it. So like if you want to get anything from your freezer, you probably need to defrost it first. So that's the same kind of idea. And the minimum retention periods for the archive storage is 90 days. So if you put anything that need to be retrieved within 90 days, that doesn't really satisfy the requirement for archive storage, in which case I would recommend you putting into standard storage. There are also some kind of like time to first byte restore time requirement and different kind of specs and different kind of like guarantee that I would not go too much into. But just remember, if you want to retrieve something from your archive storage, you need to wait a little bit. But however, the use case for having archive storage than your standard storage is that it's cheaper. And then if you have tons of data that you don't need for a long time, then you probably should put into your archive storage. Here, basically talking about different scenarios. You can use object storage. You can use it as a content repository, which is highly available and durable content repository for data, image, and logs and video. And also archives and backups. If you want to back up, for example, your blog volumes, you can back it up to object storage if you want to back up your database, which is huge, big. And then you can also back it up into object storage. And also like large data sets, different IoT data sets or big data sets, you can always use it as a data lake for all the unstructured data. Next one, let's talk about the kind of service features. One is strong consistency. Object storage service always serves the most recent copy of data when retrieved. And durability, the data is stored redundantly across multiple storage server across multiple ADs, and the integrity is actively monitored. And also, object storage is very, it can be very good on performance when you access from the same network. You can also have customized metadata, and most of all, you can also have encryption so that you know your data are safe. Let's talk about some concepts or terminologies for object storage. Most importantly, and the most lower level is an object. So object that represents all data regardless of their content type, whether they're JSON or whether they're a text file, CSV, or MP4 image styles, different kind of things. They're all objects, and each object is the object itself, along with some metadata, including like where the objects are from and different kind of who's the author, what time it was created, those kind of metadata of the object. And then one level up is a bucket. Bucket is a logical container for storing objects. So each object needs to be in one of the buckets. One thing that I do need to mention that we do better and a little bit more convenient than our competitor, AWS, their storage service is called S3. Their buckets, so our bucket name must be unique within your tenancy. However, it doesn't need to be unique across all the tenancies out there around the world. So for example, my tenancy, I can have a bucket called mydev. Your tenancy, you can have a bucket called mydev as well. However, that's not the case with our competitor S3. In S3, you need to have a unique bucket name across the entire domain, the entire S3 domain and internet. So for example, if my tenancy, if I choose mydev as my bucket name, you cannot choose mydev as your bucket name anymore, because in the entire S3, there's already one existed like in my tenancy, and that's mine. So you cannot use it. Just a little bit inconvenient in that case for S3. So I feel like, personally, our way, Oracle way, is better. And then continue talking about object storage concept. The highest level is namespace. Namespace is a logical entity that serves as a top level container for all buckets and objects. And then namespace is global, it's spanning across all compartments and region. And then each namespace is unique to your own tenancy. Within the namespace, your bucket and objects exist actually in a flat architecture, but however, you can simulate a directory structure using like slashes, like folder1/folder2/folder3 to kind of simulate a hierarchy structure. So let's talk about some capability and some kind of additional features. First one is to manage access and authentication in the buckets. If you just want someone to access the object in the bucket without their own credential, like for example, they're not a user in your cloud, you can generate a pre-authenticated request, which is a URL that includes the token for them to access it. So if they have the the link, they can click it and download it at like without any access to your tenancy. And you can also set a time limit, like also like a period, expiration dates for when the pre-authenticated request is gonna expire. So you can invoke it in any time, so it's easier than S3, which you need to set like permissions and stuff like that. And second one is like the public/private setting of the bucket. By default, at creation, your bucket is considered private, and access to the bucket requires authentication and authorization. But you can set it to public if you want to, so that anyone can access to it. But that's a little bit dangerous. Like back in the day when S3 make all the buckets like public by default, it created lots of problems, lots of hacks, and lots of leaks and stuff like that. So personally, I don't recommend you to set your bucket to public. Just grant whoever needs access. And then if anyone who is just like temporarily needing something, you just give them the pre-authenticated request. Another feature is cross-region copy. Because object storage is a regional specific service. So if you upload something to the object storage, it actually creates multiple copies in the same region in different domains. So like for God's sake, if one region that goes down, the other region can serve the same objects to you, regardless of other regions' status. So it's very doable. But however, it still means that your object is living within one region. But if you want to copy your objects into another region, you can actually do that in Oracle by using cross-region copy. But before you do that, you do need to give object storage the permission to do that. So here, the sentence in purple is the permission that you need to copy and paste into the policy field in your cloud tenancy in order for the object storage to perform cross-region copy. And then let's talk about lifecycle management. So let's define lifecycle management as the rules to automatically archive or delete objects after a specific time, given different kind of like parameter or kind of conditions. For example, you can say the prefix of the data is my name or something, and then give it that condition and then say 30 days later, let's delete all of them. So that's something that you can perform automatically on Oracle. But however, same as the cross-region copy, you do need to allow object storage to do that. So it's not enabled by default. It's some kind of like, I wouldn't say hidden feature, but it sounds like Easter egg features for you to use. So yeah, and then as the slide suggests, you can apply this lifecycle management policy to an object name or prefix level so that it only delete or archive certain objects instead of just deleting or archiving your entire buckets. So that is mostly about this lifecycle management piece. Here, basically, I talk about all the services, all the storage services that we offer at Oracle, OCI, Oracle Cloud Infrastructure. This is just a summary page of the services I talk about. I'm gonna pause here for Q&A, and then you can look at this table if you have any questions. And so if you have any question, please just ask me.
Thank you again for all attending the session today. We hope that you found it informative and that you'll join us again next month to learn about autonomous database versus classic. And we'd also like to offer you a chance to gain hands-on exposure in a cloud trial environment as well. So I will go ahead and copy 2 links. The first one will be to the next session, and the second one is to give you access to a cloud trial, and I'll put that in the main chat. And then again, we'll go ahead and send you in a couple of days the link to this recording as well. And you can reply to that if you have any questions that we didn't get to, and we're happy to help you. Well, thank you again. So I'll go ahead and end the meeting now, but hope to see you next time.
Thank you.